So Dan is a developer who loves empowering other developers by building tools. He works at Facebook, working on React. He has a few open source projects out there that you might use, like myself, React, like working on React at Redux, and all these things that help us try to be better and more productive developers.
Also, right before the event, he tweeted this almost a little clickbaity tweet, and I'm going to read it if you don't mind. Using a strange new API, I have never felt this productive using React before. You're going to hate it. Then you're going to love it. We'll spill some beans in a week at JSConf IS. Well, now here we are. Let's hear it from Dan.
All right. Hi, my name is Dan, and I work at Facebook on the React team. And in this talk, I want to talk about the future of React. And originally, when I planned this talk, I thought that I would talk about React 16 release and then the upcoming React 16.3 release, which finally fixes the context API, and then talk a little bit at the end about the future of React. But I was playing with some features that my teammates have been building, like future features. Some of them we've talked before, some of them we've never even talked before. And I realized that I actually want to dedicate my whole talk to these new features that aren't available yet, but I find them pretty fascinating, and I hope you like them too. So, disclaimer, I'm going to show the demos. This is a very kind of demo-oriented talk. The things that I'm showing are not production ready yet. The exact APIs will change. Don't fixate on them too much. But I want to emphasize that this is using real builds of React. So these are not fake demos. These are using actual React code. And I want to start with a question. And the question is, as library developers, we need to think about our immediate users, the developers who are building apps, and also the users of our users, that is, the actual people who are using those apps. And so at Facebook, our scale is pretty global, so we need to consider all kinds of connections and all kinds of devices, such as either high-powered CPUs like on a laptop or low-powered CPUs, such as on a mobile device, and either fast or slow connections. And we need to think about how can we, as library developers, empower the application developers to give the best user experience regardless of the device or the network. And is there anything that React can do better to enable them? So when we think about those issues, we tend to group them into two different areas. The issues related to the computing power and the differences in the computing power, and the issues relating to the differences in network speed. And I'm going to refer to this as CPU and I/O. And in the context of React, when we think of the CPU work, we usually think about creating the DOM nodes, creating components, rendering them, updating them, calculating the updates, and so on. So things that tend to be synchronous. And when we think about the I/O work in the context of React, we usually think about the data fetching and the code splitting. So is there something that React could do better in those areas? I'm going to start with the CPU area. And I have a demo. As I said, this is a demo-oriented talk. So this is my demo. Maybe it doesn't look like a real app that you built, but at least it's pretty beautiful, and it's graphics, so it's easy to see from the audience. But what I have here is I have a text box. I can type into that text box. Hello, JSConf. And I have a bunch of charts, and every time I type, the charts update. And I made it so that the longer I type, the more complicated the charts become. So this lets me show that no matter how fast the implementation of component is, eventually if the component tree is deep enough and there are enough DOM nodes, there is enough computation, it's going to slow down. And I don't mean to nitpick on a specific chart example, you can imagine that instead of a chart, there could be any kind of React component tree. So the main point is just that it's a heavy tree with a lot of DOM nodes, a lot of components, and it updates every time I type. And so already with this level of complexity, when I type, I experience stutter. And I'm the one who experiences it. Maybe you don't see it. So I build a small clock. So the clock shows how the screen updates. So when the clock is green, it means that the last frames were drawn pretty near to each other, so it feels responsive. But if you see when I type, I can see yellow and even red. This means that it takes a lot of time between different frames, so the user experience suffers. And eventually, no matter what kind of app you're building, eventually you're bumping into this problem where no particular component is slow, but you just have so many features and such deep nesting that you have this problem. So the typical solution to this is to debounce the input. So instead of updating the output immediately as I type, I can just wait until the typing finishes and then do a single update. So I can type the input is completely responsive, but then the user experience suffers in the sense that if my computer is actually powerful enough, so like I will remove some characters to make the complexity smaller, I still have to wait until to finish typing to see the results. So this program doesn't really adapt to the performance of my computer and to the complexity of the tree. And this is even more pronounced if I enable the CPU throttling. So CPU throttling is a way to emulate performance of a mobile device, of a less powered device. So I will slow down the CPU by 4 times. And now you can see that even, so I type JSConf Iceland. And even though it waited a little bit, it still froze later because the underlying problem is just that the update is big and it's synchronous. So as soon as React starts rendering, it cannot stop. Well, what if there was a way to make updates asynchronous so that React could start rendering something, but then yield back to the browser? And if there is a higher priority event, like an input, the browser could handle that first and not start the thread. So I will disable the throttling for now. Let's see how it normally behaves in asynchronous mode. So what you can see here is that when the input is short and it doesn't there is not a lot of computation, it updates almost synchronously. So it feels like as if it was synchronous. But if I type more, what happens is that instead of hanging the thread says responsive. You can see that it's mostly green. But instead, React just updates the charts less often, and they lag behind my input a little bit. But in many cases, this actually doesn't matter, and it's a completely fine compromise from the UI perspective. Let's see what happens on a slow device. So I enable the CPU throttling 4 times slower. You can see that it does stutter a little bit, but it's mostly green. And it tries to catch up to my typing even though the device is slower, compared to the synchronous version where it just stutters on every keystroke. Of course, in Relapse, you often can optimize updates specifically, so maybe only part of your updates. And so you can just update those components and avoid a large update. But not every, there are also scenarios where you just need to mount a new heavy tree. So I will unmount this chart completely and then mount it again with throttling enabled. So that's simulating a slow device. And you can see that it hangs every time. And while it's rendering the chart, nothing is interactive. So I can actually click on this clock to simulate an interaction, but while it's mounting, it doesn't register my clicks. Now, debouncing doesn't help us here because debouncing is only helpful for updates. But here, I'm just mounting a huge component tree. So let's compare this with asynchronous mode. And I still have the throttling enabled, so that's emulating a slow device. So in asynchronous mode, you can see that even though it stutters a little bit, it doesn't go into red. And interestingly, the circle stays interactive. So I can actually I can start mounting, I can click on this, interact with this. So the whole app is still working while the rendering is mounting. In fact, I can even start typing in the input, and it's going to update to my typing. So that was the CPU demo. And I want to emphasize that this is not about the charts or the inputs. We've built a generic way to ensure the high priority updates don't get blocked by low priority update. And in this particular example, high priority update was updating the input, and a low priority update was re-rendering the chart, but it could have been any kind of React component, for example, a feed story that gets loaded, and we don't want to freeze the scroll while we're loading new items in the feed. And we call this feature time slicing. So it doesn't block the thread while it's rendering, and if my device is fast enough, it feels almost like it's synchronous, but if it is slow, then at least it feels responsive. So it adapts to the device, thanks to browser exposing a request idle callback API that we use for that. Also notice that only the final state was displayed. The render screen is always consistent. We don't get artifacts of slowly rendering something that is going to cause a janky user experience. We only flush when the low priority update is ready. And you might think, oh, maybe I changed those charts to it's probably a lot of work to make charts, this chart component work like this. But actually, I just used a ready-made component from NPM. I didn't make any changes to it. So we can look at the code, and it's just a regular render method. I have a charts component. It renders components from NPM. I pass data to it, and I call setState. And I use a special flag to tell React that it's a low-priority setState. And personally, I found it very helpful to use version control as a metaphor for this. So when I didn't know about version control, and I would just modify the files as I worked on them, hopefully I never did anything silly that I can't undo. So I would just work on a feature in my application. But then if suddenly in the middle of working on that feature, I need to fix a bug, now I can't do it because I only have one version of my tree, so I have to finish working on the feature first. And this is kind of how React works without time slicing. The React that you know is that it can't interrupt a long update. But when I learned version control, I learned to work on a branch. So I could start working on the feature, work on it in the branch, but then if I need to do an urgent bug fix, I just do it on master. And then I can rebase the branch on top of that. And so this is pretty much how React works with time slicing, except that you don't have to rebase anything. React does that work. So React determines how to apply a low priority update on the top. And it can continue working and then flush when everything's ready, just like I can merge the branch when it's ready. So we looked at what React could do better at the CPU side. What about the I/O, data fetching, and code splitting? I have another demo. That's the fun part. All right. I built a movie app. So you can see this is the app. It has a list of movies. I can click on a movie. It shows a detail page with movie details and the reviews. And that's basically pretty much everything that it does. So it has an app component at the top that renders either a movie list page, which is this page, or the movie details page, which is this page. So there's just two kind of pages here. And the data is currently absolutely hard-coded. So there's like a JSON with the array of those things, and we take the data by ID from the JSON. So what if I wanted to change that to fetch data from a remote API? Let's go to the movie page component. I'm going to remove the hard-coded movie details JSON import, and instead I will import fetch movie details from API. All right, and I'm going to use another function that I'll import from the future. Again, the exact API doesn't matter. It may change, most likely. So I will call it createFetcher for now. Then I'll go to the movie details component. So currently, movie details reads from JSON object. But I'm going to do something different. I will create something called a fetcher. So I'll call it movie details fetcher equals createFetcher. And I will pass my promise returning function, fetch movie details, to it. Now the next step is going to be a little bit controversial. So if you know React, you probably know that you're not supposed to do data fetching in render. So in this talk, I'm going to bend this rule a little bit. And I just want you to follow along with it and see where it leads us. So when React came out, it was pretty controversial, and I think we can make more controversial things. All right, so I have this fetcher object, and it works as a cache. It has a single method called read. So I'm going to call movie details fetcher.read and pass the ID. So what's going to happen is that when React renders the movie details component, it will try to get this data from the cache. But the data is not there because it's not fetched yet. So React is going to fetch the data. And React is going to prevent the entire update from occurring until the data is ready. There is just one more thing I need to do. I need to tell React that it's actually OK for the transition from this page to the details page to be asynchronous. So again, the exact API is probably going to be different. But here in the movie click, where I set state show detail true, I will call something called defer set state with the same state. So let's see if that works. I click on an item, it waits, and it loads. And if you don't believe me, I actually built a small debugger here. So it shows the pending requests and how requests happen. So if I remove everything from the cache and I click on the movie, there is a request here. And when it comes back, React renders the detail view. Now you might think, oh, there must be erase conditions. And maybe you think that this screen is not interactive while it's fetching. No, it's interactive. I can click here, I can click here. It's going to load the right one. Now it's in cache. I can go back, I can click on this movie, it's in cache, so it renders instantly. However, what if the latency is high? What if the network request takes a lot of time, like in this example, 3 seconds, but it could have been like 15 seconds. So now if I click on a movie, it seems like nothing is happening if you don't have the debugger open. So that's not a very good user experience. But we can improve it. So I'm going to import something else from the future. It's very convenient to have access to the feature. I'm going to import a component called a placeholder. And I'm going to say that if anything inside the movie page is not ready, we're going to render a placeholder. If the movie page takes more than 1.5 seconds to load, so that's a delay milliseconds argument, then I want to show a spinner. So what React is going to do is it's going to try to render this component, but if any of its child is going to render as much of the tree as it can. But if any of the children are waiting for async dependencies, it's going to wait for those children. And if it takes more than this amount of time, it's going to display the placeholder until those dependencies are resolved. So let's see how this works. I click on a movie. In this case, my default latency is 1 second. So it actually feels almost instantaneous. So I don't see the loading indicator. But if the latency is high, 3 seconds, and I click on a movie, then it shows the placeholder, and then it shows the real thing when it's ready. Here's another interesting thing. Even while it's showing the placeholder, the app is fully interactive. It is never frozen. So I can pause all new requests, start fetching, imitate the fetch. It takes a long time. But say I want to go back. I can actually go back. So the screen is always interactive. Now we just fetched the details, but what if we want to fetch the reviews as well? To do that, I'm going back to movie page component, and I'm opening let me remove the hard-coded JSON import, and instead import fetch movie reviews. And I'm scrolling down to my movie reviews component that currently reads it from JSON. And I create movie reviews fetcher. Create fetcher with fetch movie reviews. And again, I just call read. I said, movie reviews fetcher dot read for props ID. So movie reviews and movie details are siblings, but React is going to wait for both of them before continuing. So let's see if the latency is 1 second, it's waiting for both, but both resolve in time, so it doesn't display any intermediate loading states and the page doesn't jump with spinners. But let's say that I pause new requests, I start fetching, I'll let the reviews come through first. Well, React can't render reviews alone. It's important that the screen is always consistent with what's in the render methods. So React is still showing the placeholder. But when the details of the movie are loaded, this is when it shows everything together. Now this may be fine, but there is a downside. What if I actually don't care about the reviews that much? And I don't want to delay showing the details if the details loaded first. Well, to do that, I use the placeholder component from the future. So I can wrap the movie reviews component in a placeholder. And I can say that if the movie review specifically took longer than a second to load since the interaction, we actually don't care about them that much, and we're going to show another spinner with a medium size. Let's see what happens. So I pause all new requests, I start loading a movie, and I load the details first. It shows the details, but the reviews are still loading. And when the reviews are ready, it shows the reviews. And again, there are no race conditions. I can go back, I can clear this, I can start fetching this, start fetching the reviews, go back, go here, start fetching the details. It knows exactly what's the right thing to do, and it respects the props that I pass to it. But we can still make the user experience better. For example, when I just click, if the delay is less than a second, it's nice that the screen pops in when it's ready, but before that happens, I don't have any visual indication that something is happening. So can we fix that? Yes. I will go into the app component, and I will import something else from the future. It's called loading. So this is not the final API. This API is most likely to change. But for now, loading is just a component that gives me a render prop called isLoading that lets me decide what to show. For now, I'll copy paste what I already have here, so either the detail view or the list view. But I already prepared my movie list page in a way that I can pass a loading ID to it, and it will show an inline spinner. So for example, if I pass loading ID equals 1, it shows a spinner like this. If I pass loading ID equals 2, it shows a spinner on the second movie. So what I'm going to do is I'm going to make loading ID an argument to render list. And I'm going to call render list. So if we are currently loading, which is what we wanted to ask React, then I just pass the current ID. Otherwise, I pass null. And I can even remove the main placeholder now. Let's see what happens. So now when I click, it shows an inline spinner. And again, no race conditions. I can click here, then click here. It shows the right thing. The screen is always interactive. And now this is cached. So this is all cool, but we can still improve the user experience even further. For example, currently we show the movie page. We load the code for the movie page right away, but we don't actually need it until we click on the movie. So I'm going to replace this with a component that does code splitting. So I call it movie page loader, and I define it above. It takes the props and passes them to movie page. So if we are code splitting, do we need to show a spinner while the code is loaded? Or does the question even make sense if we have these new primitives? Let's see. I'm going to import create fetcher again. And I will create a movie page fetcher. To fetch the movie page, I will use the dynamic import syntax. So I will return a promise that returns import to movie page. And I'll remove the static webpack import, so it's not going to be in the initial bundle. Finally, to get the movie page component, I call the read function on the fetcher and read the default property from the module because it's a default export. So let's see if that works. I click here, there is no global loading indicator. If the request takes fast enough, yeah, I just added code split into my app. But if the request is slow, oh, I guess I removed the fallback, so yeah, that's not going to work. But we can check that this actually did something. So if I refresh, I clear the network tab, and I press, you can see that there is a chunk here. So you can see that this component truly was loaded with code splitting. There is still one improvement to the user interface that I can make here. You might have noticed that this movie has a taller poster than other movies. Let's say that we don't know their sizes immediately. So when I click on it for the first time, the page jumps a little bit when the movie loads. So can we avoid showing the page until the image is ready? Well, we can go to the movie page component and find the movie poster component that renders an image. And I will create my custom image component with capital I that just renders the browser image, except with a twist. I create an image fetcher, which is a fetcher. Now I need to return a promise. So I return a function that returns a promise that resolves when I create a browser image object to preload the image. And when that image loads, I resolve my promise. And I start the loading process. And now I say that the source is imagefetcher.read prop source. I'm bad at this, right? Yeah, this should be an argument because I pass it to the read, so it's going to come out here. Now, if I click on it, that didn't work. Okay, it's a live demo. Some things, that's why you should look at lint warnings. So let's use the image component. Now I'll click on it, and it jumps on the page when the image is ready. And this was the I/O demo. We built a generic way for components to suspend rendering when they load asynchronous data or dependencies or really anything asynchronous. And we call this feature Suspense. You can pause any state update until the data is ready, as specified by the components. And you can add async loading to any component anywhere deep in the tree without plumbing all the props and state and hoisting it up and using Redux or anything you usually do for that. And on a fast network, the upside is that you can make it appear very fluent and almost instantaneous without the jarring cascade of spinners that appear and disappear all the time. But on a slow network, you can be intentional about designing the loading states and not just let them be artifacts of how the code is written. Instead, you explicitly design which loading states you want the user to see and how granular or coarse they must be. And there is both a high-level and a low-level API. So the API that I showed you is a high-level reference implementation that we're going to provide, but there is a lower-level API that libraries can use to integrate with this. And again, I found it helpful to use version control as a metaphor. So when I use version control and I start working on something, I do this on a branch. But sometimes maybe I can't continue working on the feature because I'm waiting for the designer to give me the final design. So I put that work aside and I can do something else. And this is how React Suspense works, is that React knows that some of the children need some async dependencies, so it just suspends that tree. But it can still handle higher priority events, so this is why I was able to click on everything and continue navigating through the app. And later, just like I can rebase my old branch when I finally have the designs on top of the master, React rebases the suspended update and can continue when the async dependencies are satisfied and then committed to the DOM. So coming back to my question, how can React enable better user experiences for people with different devices and different networks? We think that time slicing helps the CPU case, and the suspense feature helps the I/O case, is that we can be more intentional about designing for slower devices and how they should behave, but we can also provide better experiences of fast devices. And you can see that there are a lot of similarities between these two axes. So this is why we don't really think these are separate performance problems. We think that both the main problem here is not the performance, but scheduling. And the solution has to think about the scheduling. And so we call this suite of features async rendering in React. And our goal is to let app developers adapt to users' constraints, such as device and network, to make fast interactions feel instant without the janky things popping out of the screen, and make slower interactions feel responsive and be designed intentionally. And importantly, this is still the React you know. This is still the declarative component paradigm that if you use React, that's what you like about it. So it's not ready yet, but these are not fake product, like you saw me really using it. So it's a real thing. There is a pull request for this, and there is more work to be done to enable this and to ship this as a stable feature, and we hope to deliver it this year. Thank you.